That will be, so we can proceed further, or else I'll just start with from your mind, from your thinking. If you can say what is Docker and why we need that.
Docker, in simple way, we can tell as a container kind of thing.
Yeah, it is a containerization platform to create containerization platform. Yes, but okay. So let me just tell you. Okay. So what is Docker actually? Let me share my screen. We can
As
say,
I
As
know,
per my understanding,
yeah,
as per my understanding, development team they'll be using their own softwares and tools and versioning all these things that they're doing, and they'll be developing the application. And when they're trying to send this code to the testing team, so they'll be facing some issues because of that environmental software, all these things. So to avoid these issues with the testing team, what are the softwares, versionings, all the tools they have used the development team, they will be doing all these things into one container, and they'll be sending this to testing, so that our testing team also uses the same container to validate the code, so that to avoid many issues in the testing environment.
hmm. So that
Correct me
is,
if I'm wrong.
yeah, that is one aspect actually. That is the main thing why with relates to the issues and all. So yeah, that's correct actually. And there are many other benefits of using Docker. Okay, not only this one, this is the major one, but there are many other things which will make our delivery make our application, the reliability, application security, application with respect to everything. It is actually much faster deployment. Also, you can do by creating containers. So you can your applications, which is designed in a monolithic application, means that we can break into different pieces like the microservices, different services, and then we can run it in different servers. So that will be really very cool tool actually, if you want to say this containerizations, if you're done. Okay, so let me tell you and explain more on this, what is this containerization, and why we need this containerization, what was before and what is the benefits, so what is the drawback, everything will explain in this class. Okay, let me share my screen. Okay, so what is Docker? First thing, Docker is a platform used to containerize your software. Containerize your software. Software means your product, your application, using which you can easily build your application, package them with the dependencies required for your application into the container, and further, these containers are easily shipped to run on other machines. Okay, suppose let's think about one example. Suppose you have an applications built in Java, and that's required some few libraries. Okay, and your application has a backend, that is suppose MySQL DB database, and your Java applications is required MySQL library or the DLL. Okay, to build together and create the application. Okay, so what we need then, we have to get together all the dependencies, all the libraries, binaries together, bundle it and create one package. Okay, and that package need to be shipped to any machines, and that machines we can create a container, and that container will hold everything inside it for the application to run. That means if you are running a container on CentOS machine, Red Hat, on Ubuntu, on Windows, or any other machines, that will not differ, because the application is running inside a container, and the container holds all the dependencies. Now the application is not dependent on the machine's hardware or software. It is dependent on the containers, what the container contains. Now our application will run perfectly, right? So what it does again, Docker is simplifying the DevOps methodology by allowing developers to create templates called images. We'll discuss further. This is just overview, and when we go forward, we'll just learn what is image, how we can create our own image, and all these things we'll learn. Okay, so what it does, Docker is simplifying the DevOps methodology by allowing developers to create templates called images, using which you can create this lightweight virtual machine called as container. Okay, so Docker is making things easier for software industry, giving them the capability to automate the infrastructure, isolate the application. So application isolation is most important, and this is what the microservices comes into the picture. We are isolating the applications. It's not dependent with each other. If anything breaks, the other things will work perfectly. Okay, that is why we are isolating the applications, and the maintaining consistency and improving the resource utilizations. That's also very good point of improving the resource utilizations. Okay, so that means we know with the Docker we are going to create the containerized. We contain the containerization. We are going to make it using Docker. We create the container and put the applications. So before learning containerization, we should know what is virtualization, how how the applications were working before containerization. Okay, so far every companies, I believe in your companies, we are working VMs, right? Virtual machines. We have multiple virtual machines. If you have one, two servers, like I'm talking about one company. You are there, right? So you have one production server, you'll have 1 year server, we'll have month end server, you have year end server, you'll have different snaps and different snapshots, and you'll have different right, servers will be there. So these are not but the virtual machines. Okay, so what is this virtualization? Virtualization refers to importing a guest operating system on your host operating system, allowing developers to run multiple OS on different VMs. That means we are going to create virtual machines on one single host machine. Suppose you have a machine or a server having higher configurations. Suppose you have 500 GB of RAM memory and 32 CPUs or 64 CPUs or something like that, and you are going to make multiple machines. You don't want to create different and separate host machines. Okay, before what it was there, your application you would have before virtualization. If you see before virtualization, what it was there, you'll have to suppose you have 3 or 4 applications is running, or the same applications required to run multiple machines. You have to create multiple servers, right? You have to procure multiple servers to host your different applications. But with the help of virtualization, what it simplifies, in one core server, in one host server, you can right segregate or partition the server to create different virtual machines on top of that servers, and those virtual machines will use the same host machines hardware, but the operating system will be different. Suppose one machine is having 3 virtual machines, and 3 virtual machines we have to install 3 softwares, sorry, 3 operating systems. With the base operating system, again on these 3 virtual machines, we have to install 3 different operating systems. Okay, so that is how what happens here virtual while they run on the same host, thereby eliminating the need of provide extra hardware. Okay, that means suppose my laptop, I have one laptop, I want to create 2 3 virtual machines. Same laptops I can create 3 machines, but those 3 machines are going to use my laptop's hardware. Same hardware will be used by those 3 virtual. So here I'm eliminating the hardware cost with the help of virtualization. Before, if you have before virtualization, if you have to create and use another applications, you have to what you have to do, you have to purchase another laptop, another desktop, another machine, another server, then install it. But with the help of virtualization, I create the number of machines based on the resources, right? So these are the benefits: enabling multiple operating system on the same machine. It was cheaper than the previous method due to less compact infrastructure setup. If there is any failure state, was easy to recover and do its maintenance. Faster provisioning of applications and increase IT productivity, efficiency, and responsiveness. Okay, that is what the virtualization. Then we'll talk about the containerization. So what is the containerizations? So we'll learn what is the virtualization, what is the benefit, and how it will make us like benefit from using the virtualization. Now we'll talk about the what is containerization. Okay, so the containerization is a technique where the virtualization is being brought containerizations to an operating system level. Here in containerizations also we are going to use the term virtualization, but the thing is the virtualizations we are using different machines with operating systems to be installed on the machines. But in case of containerizations, we don't need separate operating systems to be installed there, because the containers are going to use the same operating system, same hardware of that machine. What it says, you virtualize your operating system resources. It is more efficient as there is no guest operating system consuming the host resources, as containers utilize only the host operating system. So in case of containerization, what I'm going to do here, suppose I have my host machine, my laptop. I'm just going to create suppose three applications to run. What I can do, I can use Docker to create containers, and in these containers, I'm going to put my three applications. Okay, so what will happen? These containers will use my laptop's hardware as well as the software, the operating system. Here, what else we are saving now in virtualization? We saved the infrastructure cost, we saved the hardware cost, right? By making virtualization again. But what happens in virtualizations, we have to pay for operating systems. Operating system is also costly, right? So we have to pay for operating system. But in case of containerizations, we are going to eliminate the hardware cost, we are going to eliminate the operating system cost, OS cost, because the containers are going to use the same hardware and same operating system of the machine. Okay, so that is what we are going to use it. Now what happens here, containerization is a lightweight, see this is what you can just containerization is a lightweight technology acting as alternative to the hypervisor virtualization. Okay, meaning as hypervisor virtualization, and bundle any application in a container and run them without thinking of any dependencies, libraries, or binaries. Okay, that's very important usage of the containerization. So what is the advantages? Containers are small and lighter in weight because they share the same OS kernel. Because see, in case of virtualization, see, I'm correlating with virtualization and containerization all the time when I just cover all these topics, because you can really understand what is exactly the benefits we are going to get out of the container. Okay, so in case of virtualizations, when you install operating system, the operating systems are going to use the, it will have this different OS kernels, because every OS operating system will have different kernels, right? Three virtual machines will have three kernels, and that will make your system heavy. Okay, but in this case, what happens? We are going to use the same OS kernel of the host machine. We are eliminating those things also. Now our containers will be the lightweight, right? And it does not take much time to boot up. It's very within a fraction of seconds. If you run and boot on an application, it within a fraction of second it will boot up. It's not required any, because it is not dependent any, it does not have extra kernel, it does not have extra setups, right? High performance with lower resource utilization. I'll just whatever I'm just covering, I'll just explain with the diagram below. Okay, don't worry. Okay, so here is the diagram, whatever I just discussed, the theoretically, and here I have created a diagram. So you'll understand more on this diagram. So here the virtualization is there, and here the containerizations. I've just given a virtualization versus containerizations. We'll see how the whatever I just told you, the same things been picturized here. Okay, In case of virtualization, what happened? We have host with suppose my laptop. To make virtualizations work, we have to install one software is called hypervisor. Hypervisor, you know the VM company, VMware, right? There is a company VMware who provides hypervisor, the tool. So what happens? We have to install the hypervisor there in the host machine. Using this hypervisor, we have to create virtual machines. Suppose here we have three VMs and we have three applications to run.
What is the actually use of that hypervisor actually?
So
What it's doing?
yeah, so it will help us to create the virtual machines. It is a software, it is a tool which will help us to create the virtual machines. You know,
Okay, okay.
there are many tools available. You can use VMware, the VMware, right? You can use Oracle Box, Oracle Toolbox to create the virtual machines, right? There are many ways you can create the virtual machines, and that when you create the virtual machines by backend, it's working the hypervisor, which helps us to create the virtual machines. Okay, now if you see the hypervisor will be there. On top of that machine, we have three machines created, and three machines will have guest operating system. That's called guest operating system, and this host machine will be host operating system, host OS. So this guest OS will have, suppose app one is required by binaries and libraries, then we have to install separate libraries binaries on this one, and here also we have to install separate binaries, and then all three applications will be deployed on three machines. So what will happen? These all three have separate guest OS. So it is costly because we are going to pay for this operating system, and they are going to use. But the only thing is they are going to use the hardware of the operating system, but the kernels are the separate kernels. Okay. But in case of containerization, what will happen? We need a container engine on top of our host engine. So container engine who provides Docker. I'll show you, and I'll show you the installation, how you can install using Docker engine and all, how you can install Docker and Docker engines. I'll show you. Now, in my laptop, I have suppose installed Docker. So what will happen? This using this Docker engine, I can create the containers. What will this container will do? See, here we don't need any guest operating system. Here we don't need any guest operating system. However, what we can do, we can just create a container, and inside the container, we can put all the binaries and libraries. And suppose here we have three containers, and these three containers we are running on this host operating system. These containers will use the operating system, host operating system, and the hardware and infrastructure of the machine. So here we are eliminating the hardware cost, we are eliminating the operating guest operating systems and everything, right? So, and this is the lighter weight because it does not have the kernel, which makes it heavy, right? So we don't have any kernel chip. So this is how the containerizations happens, and this is how the virtualization happens. Here are a few examples. Yeah, please.
Yeah, for example, you take one window OS is there.
Mhm.
Okay, we installed one VM. Where we VM one virtual machine we installed.
Yes.
In that virtual machine, in application we can run 3 to 4 means OS.
Hmm. 3 to 4 ways.
Yeah. For
You
example, you think that for our environment, we need 2 or 3 ways like that. We require Red Hat Linux, we require Fedora, we require
it
something
don't
like that,
have,
CentOS or something.
you cannot tell like we need three OS. We need three virtual machines. If you are talking about virtual machines,
Okay, means mm, we needed 3 virtual machine then.
yes. So you need suppose no, I'm talking about virtual. If you're talking about virtual machines, virtualization, then yes, you need virtual machines three to run three applications. But if case of containerization, we don't need any virtual machines. In the same machines, we can create containers, a number of containers, as long as you have the required resources.
Okay. For example, if your RAM memory you divided into the virtual machine.
Mm-hmm.
Okay, three to means for example, Windows is the main host.
Mm-hmm.
Okay,
Mm-hmm.
another three are on the top of. We can divide it the RAM
Mm-hmm.
to the virtual machine.
Mm-hmm.
But how in containerization, how can you do it?
In containerizations, how we'll do it, right? That's why I told you
Yeah, yeah.
containerizations, we don't need any extra operating systems, because all the containers it will contains, see, these are the containers. Okay, all the containers, what will contain, it contains all the binaries and libraries for which the application, in which the applications will work, right? So those libraries and binaries and the application will work on the host operating system. If you can see my cursor, it will work on the host operating system, right? On this operating system it will work. But here in the virtualization, the applications will work on the guest operating system. If you are going to create
Okay.
virtual machines, if you are going to create virtual machines, then you need guest operating system to be installed. Suppose you have here Ubuntu machines there, one Ubuntu machine is there. So one more thing, guys, Windows kernel and Linux kernel are different. So if you have Windows machine, you cannot create Linux virtual machine on Windows. For that you need another kernel to be installed, another tools to be supported to create that. So if you have, suppose, CentOS host machine and you want to create three Ubuntu, then you can create three Ubuntu machines, because that kernel will support the host operating system's hardware and these kernels, right? That will be easy to create and it will make it work. In containerizations, we don't need anything, because everything will be containerized into one container, and that container will have all the required dependencies for the applications to run. And if you put that container in any host machines, based on the operating systems, it will work. Okay, all these examples whatever I just told you, explain further below. Okay, so let me just give these differences, and then we'll follow with another diagram which will clearly differentiate between the resources usage, and you will clearly understand. Okay, now the virtualization, as we discussed, virtualizes the hardware resources. It virtualizes only the operating system resources. It requires the complete OS installations for every VM. Suppose you're going to create three VMs, means three operating systems to be installed on three virtual machines. But in case of only the underlying host operating systems kernel is used, because here no operating systems for containers, it's being used the host operating systems. Okay, this is the basic fundamentals of Docker and containers what we are going to use, guys. You may get questions on that, but this is very basic level questions, and the interviewer must because for freshers and all, or for 1 year 2 years experience, 1 year experience, they may ask you, if you have, if you tell I have some knowledge, then they'll ask this kind of very simple questions only. Okay, but if you have experience, they will not come into this level to ask this kind of questions. But be sure that you don't know which interviewer is taking your interview, right? They may ask you questions from that, and you should know all this differentiate, and you should know difference between virtualization, difference between containerization, why we are using containerization, what is the benefits, all these things you know, right? All these things I'll discuss the further. Okay, so here, as it is using kernel is installed again for every virtualized OS, it is heavyweight, and container is lightweight, because it is going to use the system's host machine's system kernel. And limited performance, light native performance, fully isolated, process level isolated. Okay, both isolation is happening here. We are isolating the applications because we are keeping out of this host operating system. This is the system level isolation, and this is process level isolation. I'll just explain you further why, how it is happening this. Okay, now this is what is the architecture. Now this is what the diagram, and this is what difference between virtualization and containerization. So before moving to the Docker architecture, let me explain you what is the other beneficial here. Okay, so what happens here, as we are talking about the I think okay, let me copy this diagram, put it here. It is a different, it's from here. Okay, good. Okay, so as we are discussing on differences, virtualization containers, so it's best place to place the image here. In case of virtualizations, as we are talking, right, it is using what? Suppose we have 3 VMs. What we are going to do? It the virtual machines. Which can anyone answer? What hardware it is going to use? Suppose we have 3 VMs in one machine. Which hardware it is going to use? What is the memory? What is the uh, storage? Which storage? Which memory it is going to use? I know everyone know the answer, but
It will be RAM memory will be it will be used.
Yeah, RAM.
the host memory, right? The host machine's memory. That means, see, that is why the virtualization, right? I told you the virtualization, are you going to use the hardware of the base machine? The base machine, suppose in my laptop, I have created 3 machines, virtual machine in my laptop. So those machines, those servers are those virtual machines are going to use my laptop's hardware. Okay, my laptop's hardware is going to use. Suppose I have in my laptop, suppose I have 16 GB of memory, 16 GB of RAM. Okay, and I have created 3 VMs. If you see this diagram, I have VM1, VM2, VM3, left hand side. Okay, created, and I have in these 3 VMs, I have 3 different applications. VM1 one application, VM2 one application, VM3 applications, and I have allocated the storage, sorry, memory. I have allocated the memory for VM1, suppose 6 GB. While creating the virtual machines, we have to allocate the memory for each VM to use. Suppose out of 16 GB, 6 GB I allocated to VM1, 4 GB I allocated to VM2, and 6 GB I allocated to VM3. Suppose in VM1 I have one application which are going to run in this one. What happens? And this application are using only 4 GB of memory, only 4 GB of memory, and VM2 only using out of 4 it is using 3, and here out of 6 it is only using 2 GB of memory, VM3. Okay, what will happen here, guys? Out of 16 GB memory, it is only using 437 to 9 GB of memory, but the rest are wasted because once it is allocated, you cannot free the memories. Okay, once you allocate it, you cannot free the memories. So all 16 GBs are now allocated, because once now, in case suppose you got another project and you need another applications to host on your machine, so what you will do now? You cannot create another VM because you don't have any memory left. You need another machine. Either you're going to create or increase the memory, right? The one thing is we have to increase the memory. So to increase the memory, to increase the RAM, you need to buy it, right? You need to procure it. You have to pay for that. So you have to, suppose 16 GB memory you have, and you are going to get another 8 GB of memory because you got another applications to be added and another VM to be VM4 to be created. So you have, as there is no space left here, how many wasted actually here? 7 GB wasted, because out of 6 GB, if you see the VM3, the application whatever is hosted on VM3 is only using 2 GB. A rest 4 GB is wasted. So, but in case of Docker, in case of virtualizations, sorry, containerization, in case of containers, in case of Docker, what will happen? Same 16 GB memory, and we don't have to allocate any. Suppose you allocated 4 GB here, allocated 35 GB or any GB, 10 GB or something you allotted here. But the applications, whatever you are going to run on these containers are going to, suppose this container and application is running only 4 GB, requiring only 4 GB and 3 GB and 2 GB, up 1, up 2, up 3, and the rest of the memories are free. These applications only use the container, only use the memory which is required. We don't have to separately allocate it. Whatever is allotted, yeah, they are going to use it. The rest will be free. So here out of 16 GB, suppose 9 GB is occupied by the containers and applications, but the rest will be free. So the 7 GB can be allotted to a new container. And in this case, if you want to increase in another application, you can easily, because we have 7 GB left, we can easily create another container which can use the 7 GB of memory. So this is the resource benefit. This is the hardware benefits we are going to achieve out of the Docker or VMs. Okay, now you clearly understand the differences, right? Then if you have any doubt,
Yeah, yes,
let us
Ranjit.
know. Yeah, or else we'll just move forward to the Docker architecture, which is also again very important to learn. So that is why I'm just clearly and explaining you.
Ranjit, are you sharing?
Sorry,
Are
hello.
you sharing this document?
End of this class, I'll share this document. Okay, I'll share the PDF file of this. Don't worry.
Okay.
So the Docker architecture. Okay, this is very important, guys. You need to first understand it. If you read it, you'll not understand, guys. Definitely, I'll see if you read this, because all these are even more than this. You can get it from internet. That is what I am telling you. If you understand the concept, if you understand why you are going to use Docker and what is the benefit, what is there in the previous, and what we are going to get it. If you understand clearly, then no need to follow this documentation and all. You can easily explain by your own thought what you are thinking, right? Okay, anyway, just follow this documentation, keep it handy for future reference. If in case of you forget anything, you can just go through that. Okay, I'll share this documentation, don't worry. Now, Docker architecture. Okay, so this is how, it's very simple architecture, guys. It's not so complicated. One second, guys. Okay, so sorry, guys. So Docker architecture, this is very simple architecture. It's not so complicated. Anyone can understand what is this, and it has only three steps, like three steps as the architecture. We can say client, Docker host, and registry. That's all. Client, host, registry. That's three only we have, and we need to understand what the client does, what the Docker host does, what the registry does. Okay, Docker uses a client server architecture. As you say, client and Docker host. This is a server, client server architecture. It's very simple. Client server architecture. The Docker client consists of Docker build, pull, and run. See, Docker build, pull, run. Three only. Okay. That is what we are going to learn on this, and it will be very simple to learn and to understand. The commands will be easy. I'll show you. Then the Docker client talks to the Docker daemon. Docker client talks to the Docker daemon. So Docker daemon, where it will be? Docker daemon will be on the Docker host in the Docker server. The Docker daemon will be in the Docker host. So what will happen here? The Docker client consists of Docker build, pull, and run. The Docker client talks to the Docker daemon, which further helps in building, running, and distributing the Docker containers. So who is responsible to do that? Remember, guys, this Docker daemon will be used in Kubernetes as well. Okay, it's very so you need to understand. You may get questions: who creates and who actually does the building and creating the container? It's the Docker daemon who runs the container. Okay, so running, distributing the Docker containers. Docker client and daemon can be operated on the same system. Otherwise, you can connect the Docker client to the remote Docker daemon. These both communicates with each other using the REST API over Unix sockets or a network. This means you can keep both client and Docker host on the same machine, or if you want to segregate the Docker server to put in a different machine, then through the REST API, you can write your code to connect to the Docker server and do the build. Okay, once it is done, build is happen. What will happen? It will create the image file, which is not but a binary file. I'll just explain further. That will be stored on the Docker registry. This is a binary repository. Docker registry is a binary registry. Okay, this is called Docker Hub. Docker registry is a Docker Hub. So let's go further between this client and Docker host. Okay, so it contains Docker client, Docker host, and Docker registry. It is called dockerhub.com. It is dockerhub.com. It's a cloud-based registry provided by Docker. One second.
Ranjit bhai,
Yes, Ranjit.
Hello, just
did you
one
try
second.
yesterday?
Hello.
No, not you, Ranjit. Another Ranjit. Ranjit Patnaik. Have you tried yesterday that one? S3 artifacts. I'm getting error. Have you tried?
No, no, yesterday I was a bit busy. Actually. Now try
No,
today. I will today I'll be doing it definitely.
Venkat, yesterday I tried, but
hmm.
I saw the same issue in the Jenkins side. I see like no Jenkins is not able to install that Git and some other plugins also. I'm
Oh,
seeing some issue.
oh, then if I install new one, many things will come.
See, actually, old one, it was there maybe like no before 15 days, 20 days back. I
Hmm.
see some similar issue, but when I tried like no new installing the new Jenkins, I saw a lot of issue in the Jenkins side. I'm not sure. Maybe some like no package maybe they have installed uh, for the new Jenkins side.
Now it's
So I
not
believe.
Vidhu.
Huh?
Now it's not allowing to install the old version one. It will be allow
Old one. Old one I didn't try. I tried. I was getting some error, but when I tried the new latest one, I see lot of issue. Even the Git it's not allowing. Some APIs it's not allowing. Lot of issue I see.
Okay, so actually I already just 1 month back we already installed that Jenkins
Uh,
everything. So I think that is the older version one, I believe. Okay, so today I will try it.
maybe.
Mm, we will
Yeah,
see.
maybe we maybe like we can try once. All we can report if anything we can all can try to fix because Jenkins is the first like to make it ready.
So
Then we
most
can go further.
most probably we have to be concentrated. As I know, I understand. Like most probably we have to be concentrated. GitHub with Jenkins and pipelines set up all details. We have a more confidence on this thing. No,
Yeah,
definitely get very job. Explained.
Okay.
Okay, even Ansible also. It's not Ansible. Okay,
Yeah.
that will be enough.
Okay, okay,
okay.
guys. So let's finish this. So we can. Okay, Jenkins. So we'll just try to fix it. If not, then we'll sit to one day together and we'll see how it is working. Those who have already
Yeah,
Jenkins there, don't mess up with that Jenkins server and try to do the practice on that server. Okay, don't upgrade anything,
sure.
because if you upgrade something, some plugins which may not support, then you have to reinstall those plugins. Because see, this is a very no, vast setup, right? Very vast setup, and you have to do all this together. And one thing is broken, then it will impact the other things. Okay, let the older version be there and do practice on that. Okay, then we'll discuss further on that. So let me finish this Docker architecture. Okay, so we saw about this as it is a client server architecture. We have client and host server here. So what is this Docker client? It is a primary way for many Docker users to interact with Docker. So we know here the clients, always the client interact the server. Through client only users can interact with the servers. So what is that? It is a command line utility or other tools which is uses Docker API in order to communicate with the Docker daemon. Okay, the Docker client can communicate with more than one daemon. That we'll see how it can be. In Docker host, we have Docker daemon, containers, and images. Here, what is this Docker object? The Docker object, see, it has only two objects. One is Docker image and Docker container. You'll get questions, what is this container and image? So a Docker image is a type of recipe or a template. Remember, it's very simple and very limited things to learn. One is Docker object, Docker image, and Docker container. So a Docker image is a type of recipe or template which can be used for creating Docker containers, including the steps for creating the necessary software. So when we are going to create the container should require the necessary binaries, DLLs, and all these necessary dependencies for the applications to run, for the softwares to run. So we'll bundle together into one image, and that image can be used to create a container. That's why the image is a template. What we need, we have to write in that Docker file, create image, and that image, whenever you need to create a container on any machines, use that image to run it. So what is the container? A container type of virtual machine which is created from the instructions found within the Docker image. So whatever the Docker image, the template contains, what the template contains, the instructions, whatever is given in the image file, it will create the container. Found within the Docker image, a running instance of a Docker image, which consists of an entire package required to run an application. Okay, so remember, image is a build time object, and Docker is a runtime object. Okay, so similarly, the Docker daemon, what this Docker daemon does, Docker daemon helps in listening requests for Docker API from the client. Whenever we execute any command from the CLI, it will directly interact with the Docker daemon. Suppose we are going to build any object, image, what will happen? We have to write on this Docker client, and when we execute it, it will interact with the daemon. Daemon will create the image for us. Same thing for container also. Okay, so these things is the daemon does. So in case you don't want to create an image, then simply pull an image from the Docker Hub. That also, who takes the responsibility? Again, Docker daemon. What these are the responsibility Docker daemon does. What, again, let me just read it out. It helps in managing Docker objects such as images, containers, volumes, etc. There are lots of concepts are there. I'll just tell you. Daemon issues to build an image based on the user's input and then save it in the registry. It does, Daemon does it. In case you don't want to create an image, then simply pull an image from the Docker Hub. This, I'll tell you again. Just okay. Just after this class, let me just remind me to tell you something about one interview. Yesterday, I have taken 4 to 5 profiles. I'll tell you something on these interviews. I'll stop recording and then tell you. Okay. In case, okay, let's start it. In case you don't want to create an image, then simply pull an image from the Docker Hub, okay, which will be built by some other user differently. Then, in case you want to create a running instance of your Docker image, issue a run command which should create a Docker container. That's why Docker container is a runtime object. Docker image is a build time. You should understand what is build time object and what is runtime object. So when you are going to create an image, you have to build something and then it will create the image. If you are going to create a container, then you have to run the image to create the container. Okay. So also Docker daemon communicate with other daemons to manage the Docker services. Then what is this Docker registry? Docker registry is a repository, cloud-based repositories provided by the Docker for Docker images which used to creating the Docker containers. All the images being stored in the registry. One can use a local or private registry or use the Docker Hub, which is most popular social example of a Docker registry repository. Okay, let me show you this Docker. Okay, so the Docker registry, it is dockerhub.com. I would always tell you guys, whatever the things we are going to learn, you can say dockerhub.com or hub.docker.com, the same thing, hub.docker.com, and just sign up yourself. It is free to sign up. Okay, and once you sign up here, you'll get your user ID and password. Let me just sign in mine. Shit. I'm just stopping my screen. Okay, 1 second. I need to get user ID and password. I forgot. Okay, you can meanwhile you can register by yourself also. Just log into dockerhub.com. Meanwhile, I'm getting my credentials. You can just log in and register yourself. Okay, it's simple, easy. Okay, okay. I just able to log into my server. Okay, Docker registry. So if you see it here, right? Okay, so when you log into the Docker Hub, let me just tell you, you'll get one page like this, and here you can see I have stored multiple images here. I have stored multiple images here. Under my ID, Docker for Ranjit, under my ID, I have created multiple images and stored over here. And see, many people have downloaded my image also. 49 people, 28, 32. There they have used my image to create the container. Okay, these are the images I have stored it here. But if you want to see some official images, normally what we do, we need suppose a Tomcat server, a container, Tomcat container, right? You just search for the image Tomcat, hit enter. The first thing you will get the Tomcat, and under side you can see here the official image. This is Docker registry, guys. Okay, Docker Hub registry. All the images, images are the binary files. Remember, images are the binary files. These are stored under this registry under Docker Hub. Okay, this is a popular public registry. Everyone can store. It has public as well as private. If you want to store your application as the private, your images, nobody wants to. For private, obviously you have to, there are some free there, and then you have to pay for something. Okay, now if you want to use this image to create your container, then you can just go for this official image. Okay, and you can see 500 million plus downloads been done. And so how to use that, this one, just click on this Tomcat, and you can simply use docker pull Tomcat. What it will do, it will just, this is the command, docker pull Tomcat. It will just pull the image to your machine. That's all. Okay, and out of that image you can create your container. I'm not going deeply now, because if I go deeply they will not understand, because I am not covered so far something. I'll tell you how to install the Docker, then we'll move forward. Okay, now suppose you want to create a Jenkins container. Jenkins container, what you'll do, search for Jenkins, and you'll find the Jenkins official image of Jenkins. You can use this Jenkins image, click on this. You can use docker pull Jenkins. Okay, what it says, Jenkins has deprecated this. Instead we can use Jenkins slash Jenkins colon its LTS. Okay, so this is a lightweight one. Okay, let me give more details about this image and how you can find it as registry details. Okay, and here about this image you can find the fine, this has deprecated. Let me just go for Tomcat. Okay, if you want to go for Apache server, you can search for HTTPD. You'll find this Apache. Okay, now let's search for Apache. Okay, see Apache server, you can find HTTPD. This is the official image. Okay, click for this. And how you'll know more details about these official images, the descriptions you can find it out, maintained by the Docker community, and the tags, different tags are there, quick reference, and some descriptions they have given about the images and how to use this image. One second, guys. Okay, so this is here also they have given how to use the images. Okay, all these things. So don't go through this now because you'll not understand. I'll just go through everything once we cover this commands and technical part. Then you can just use this one. It will be very easy, guys. I'll tell you, and you love to work on this. You love to work on this. Okay, now what I'm going to do, let me just explain on this more. So what is the other benefits? Okay, now you understand the Docker registry, right? So that is nothing but your dockerhub.com, hub.docker.com. Okay, so you can use the registry. It's a cloud-based registry or repositories to store the binary files, to store the binary images. So now this monolithic architecture and microservices architecture. So before microservices concept, the architecture, we had monolithic. So what is the monolithic architecture, guys? If you'll see this diagram, right, we'll have the application, will have the UI, that graphical user applications, that UI user interface, and then some business logics will be there, and some data access layer and the database. Everything will be on top of each other. It will be on top of each other because it will be in the one server. In one server, everything will be there. Your UI part will be there. Your database will be there. Your data access layer, business logic, everything will be there on one VM or one container or anything. One VM, suppose one server. What will happen if your server goes down? All your applications is now not available. Applications is also will down, will not able to. If anything happens in between the business logic, you'll not able to access this UI. Anything happens to the UI, the database also missing, right? One second, guys. Okay, so then is the microservice architecture. So let's have discuss about the microservice and what is the benefit of microservice architecture. So in this case, what happens if anything happens to the business logic, so the entire application is broken and it will be breakdown and you will not be access the database or not able to access the UI. But in this case, see, suppose in the microservices architecture, all your applications, suppose I have three containers, I'll create and I'll put the database in three different container. I'll create my UI in different container, okay, and create three UIs and all. But I'll have database. But all these things will be interrelated to the database one. Suppose in this case, the first business logic has some issues, but still our application is able to connect to the database. This will be one container. This container suppose goes down, we'll have other two containers which can serve the purpose, serve the requirement. Okay, if two down, then we have still one. But in this case, if anything is broken, we are not able to access the access the application. This is the monolithic, the single architecture setup, right? And this is the microservices. We are making all this in a different parts, different setups, and putting into different containers and creating it. Okay, so we are having different. Now this is, you understood what is this microservices and how it will get it. And using containers, using Dockers and Kubernetes, we are going to achieve this microservice architecture. We are going to this microservice architecture. Okay, now let's Okay, this is what we'll discuss. Now you understood, guys, details. What is Docker and what are the architecture and what is the benefit of using Docker? What is the benefit of using containers? And what is the microservice architecture? Okay, uh, that is why in the market, in the companies, people are moving towards this microservices architecture. And for that, we need the Kubernetes expert. Okay, Kubernetes people to make the applications break into different pieces, different micro services. What are the service here? Suppose three services or four services are there. We will have different microservices and keep it together and make it. So that is what we are going to learn in the Docker and Kubernetes. Okay. Now let's see how we can install Docker. Okay, guys. For installations of Docker, we can install in different machines. First thing, actually, we need to know how we can install this Docker. Let You have to always follow their official page. Okay, that's called docs.docker.com. Okay, and you'll find the download and install. If you go to the download and so this is the Docker official page. Okay, Docker official page, Docker docs, and you'll find the guides and everything will be there. But let me finish all these codes and then you can follow their official page to get more details on that. Okay, so they have their language specific. Okay, no problem. So go click on this download and install. Okay, and for the environment for Mac, they have a separate procedure to install. For Docker desktop, for Docker for Linux, which environment you are going to use. So I would always prefer under Linux. It will be easy to use and it's native to the Linux, so it will be good to work on the Linux. If Docker desktop has some limitation, because Docker, actually I have installed Docker on my Mac machine. If you see here on my machine, there is one icon is running, right? One icon is there. If you see my cursor, one icon is there. So this is the Docker is currently running on my laptop, on my MacBook. Okay, so I have installed Docker in my Mac also. So it is running on my machine. And if you want to, but Windows has some limitations. Let me show you what are the limitations. Linux, no limitations. You can install anytime, anywhere, any machines. But desktop Docker Windows has some limitations. Let me show you and how you install it. Install Docker desktop on Windows. For that, what we need system requirement. Some system requirement is there. Okay, here what else we need? See, either you have WSL2 backend or Hyper-V backend and Windows container. So for Hyper-V backend, suppose you need the hypervisor. What is this Hyper-V? This is the virtualization technique to create the virtual machines, right? That will help you to create the containers, virtual machines, and all, right? Either you can use WSL2 or Hyper-V backend. If you are WSL2, that actually some systems in your systems also it will have disabled. So when you install Docker, it will not work. First, you have to enable it. It is something administrative role is required. If you are good in the operating systems setups and the configurations, then you can go to the command mode of Windows. Then you can do that one. Okay. So what is the requirement? Windows 11, Windows 10, 16-bit home or pro versions. Okay, home or pro versions. Windows 11, Windows 10 is required, or home or pro versions, or enterprise or education version or higher. It is support, Docker supports. Okay, but prior to Docker 10, Windows 10, if you have what do you say, Windows 7, it will not work on Windows 7. You need a different tools to install Docker on Windows 7. So if you have Windows 10 Home Edition, okay, it is actually Docker Desktop is supporting on Home Editions. Earlier it was not supporting on Home Edition. Okay, now it is supporting the Home Edition, Edu Education Enterprise and Pro versions. Okay, so this is what the installations you
Can
have.
we install in AWS?
Sorry.
Can we install this Docker in AWS instance, any of the server,
Yes, yes, yes.
if it is not working?
Yeah, you can easily install. That is what I'm going to show you. I'm going to install in the AWS any instance, right? I'll show you in suppose Linux, Ubuntu, or anything. I'll show you how to install that, and it'll be very easy. Okay. And this startup Docker desktop, actually, they have created a tool, Docker desktop, which is very easy to use and very easy to handle your Docker, right? See, if you can see here in my Docker, if I click it here, let's see, dismiss. See, the tool, if I click on here, it says Docker desktop is running and Kubernetes is also running. In my machine, my laptop, Kubernetes is also running. And it has lots of other things to use, preferences, checks. It is very graphical user interface. If you are using Docker desktop, this is Docker desktop I have installed for MacBook. For Windows, if you have installed Docker desktop, then you will get similar kind of experience. Okay. If you are using Linux, we'll have to use all command lines. That is very good actually, because you'll use everything, you'll use in the command line and you'll remember all these things. Okay, if I see the dashboard, you'll get one very good user interface, Docker, how many containers running, how many servers, nodes, machines, everything it will display me. Achha, it says no containers running. Fine. Any images? Okay. So these are the images available on my machines. Okay, these are images available. I have not started any containers. Fine. Any volumes? I don't have any volumes. Any dev environments? No, I don't have any dev environments. Fine. So this is very easy to use Docker desktop too. It is the graphical user. I would always suggest you to use the command to get it. Okay, don't go for that. Okay, guys, there is a task for you. Go and install. If you have Windows, you can install it, but Windows will face a little bit challenging to install it. If you are good enough, you just try to install Windows and follow this documentation one by one, step by step, and try to do that. Okay, so let me show you the installation process for a Linux machine. Okay, Docker for Linux. So in the Linux machines, what I'm going to do here, so here we have Docker desktop for Mac, yes, Docker desktop for Windows. For these servers, it supports like CentOS, Debian, Fedora, Raspbian, RHL, Ubuntu, binaries, all these with support. So we can follow. For CentOS platform, if you want to run for CentOS or if you want to run for Ubuntu, Ubuntu has Debian flavor. Ubuntu has Debian flavor. Debian and Ubuntu has the same flavor. Suppose if you want to go for Ubuntu, so it has also some OS requirement. So those OS requirements we have, suppose the old environment, how we can do it. So simply under sudo, we have to just use apt-get, the package manager of apt-get. We can just use this one, and the installation method, you have to just set of repository. You can just apt-get update, apt-get install. It's very easy to do that. After what happens here, you're setting up the repository and then setting up the Docker engine. So this is the Docker engine. So once you set up this Docker repository, just follow the steps 1, 2, 3, and then 1, 2, 3, and then follow the engine Docker engine installations. Okay, apt-get is the package manager for Ubuntu. You can follow this one, and it has a different process also. Install from a package. If you want to install from a package, you can follow this to install from a package. Okay, now let me show you for CentOS. If you go and for CentOS or Red Hat, just go for CentOS. Suppose you'll find how to run. So this is what again for CentOS, yum is the package manager. Apt and apt-get is a package manager for Ubuntu and Debian. And for CentOS and Red Hat, the package manager is yum. So you can uninstall the old version. If you have any old version, you can use this one, or else you can leave it. So installation method, it has the same thing. Set up the repositories called yum install -y yum utils and config manager, and follow these steps to do that. Install Docker engine. Again, to the latest version of Docker engine, you can just go ahead and install it. Okay, so guys, try to install the follow this procedure and try to install. This is a task for you. And in our next class, which is on Tuesday, don't miss the class. On Tuesday, if you are not able to install this Docker, I'll just show you how to install this Docker on CentOS or any Ubuntu machines or any Ubuntu machines, and we'll proceed further. Okay. After that, after the installations will be hardly take 15 minutes, 10 to 15 minutes. If you are going to, if you are doing it, the step following the steps perfectly, then it will take 10 to 15 minutes. Once this is done, we can execute the commands to play around it. Okay, so that is the task for you today. Try to install Docker on your machine, either on your laptop, or you can just provision one AWS machine on the AWS instance, and in that AWS instance you can create it. Okay, EC2 instance. Also create an account on the Docker Hub, hub.docker.dev. This is the
Docker Hub.
repository. Okay,
Yeah.
just two tasks for you, and we'll meet up on Tuesday. Then we'll discuss. If you're not able to install, then I'll install it and I'll show you how to do that. Okay, so that's all for today. Maybe we can meet up on Tuesday and discuss further. Okay, so if you have any
Rajat, you are
doubt,
telling
then well, let me stop it. If you have any doubt or anything, we can discuss it now. Okay.